Hey everyone, this is Nick Diobertis teaching you financial modeling. Today we're going to be looking at how to load in capital IQ debt details into Python to work with them, and also how to structure our code into a Python module such that this code can be reused anytime that we want to load in debt details from capital IQ regardless of the model. This is part of our lecture segment on data pipelines. So the data that we're looking at loading in here um, comes in the form of this Excel spreadsheet. And within that spreadsheet, we have basically some header area, which doesn't really matter to us. We don't care about that. What we want to get out of this is this table which is in here. And there's a few things that we're going to have to do in order to clean up this data so we can actually work with it in our model. Before we get to that, just want to note that there is typically a second table in here that represents older data. So we don't want to use any of the data from that table, only the top table. And then some of the issues that we're going to have to deal with is the fact that these coupon rates actually have the percentage sign in the string. It's not just formatted as a percent, it actually has the percent sign in there. And so when we load it into Python, we will also see that percent sign in there. And the floating rates, we have LIBOR plus some rate. So we're going to want to be able to take that and plug in a LIBOR rate and get what the resulting rate is. And then we also have these coupon rate ranges where, for the purposes of our model, we'll just take the midpoint of that range and use that as the coupon for the bond. Then one other thing is that in order to do value calculations with these bonds, we're going to want to get that into a number of years for maturity. And so we're going to be converting these dates into a number of years from today. And then some of the maturities only give a year. And so we're going to assume those are at the end of the year and handle those that way. So that's an overview of all the issues that we face in loading this in. So now let's look at some Python code to make that happen. And throughout doing this, then we're going to try to make sure that it's standard and reusable such that even though this is for Walmart, we can then do the same thing, or we can then use the same code to load any other company's debt details and have them all cleaned up and ready to use for our model. So coming over to the Jupyter Notebook, we've talked about two approaches in the course which will be useful to load this information in. We can load it in using Pandas, or we can use Excel wings. I will generally go to Pandas for any usage that doesn't require back and forth between Python and Excel wings. For the most part, unless I'm just trying to grab a single value out of Excel, then sometimes I'll still use Excel wings. But Pandas generally is a lot more compatible. You can run the code on Linux or somewhere else that Excel is not installed and still get the same result. So I generally will prefer Pandas, and that's what I'll use here in this video. So import Pandas, and then I'm going to load the file into a data frame. The Walmart debt details, I have it here in the same folder. And then we'll see what we get. So we can see right away that this does not look good, right? We got a bunch of junk in here. This is not at all the table that we wanted to get. We've got all these unnames. We got a bunch of missing values in here. Basically what we're seeing here corresponds to this top part, where indeed there are no column headers, and we've just got some junk up here we don't care about. The actual table here starts in row 13. So one thing I can do to cut off this entire top area is there are a lot of options for the regex command, as you can see. One such of those options is skip rows. So we can tell it we want to skip 12 rows while loading it in and just start from the 13th row, which is where we know the data starts. So now we can see that we got the actual names of the columns in that table. That looks good. And it looks like we got the values of that table as well. Now what we can also see is we have, these last two rows are junk. So let's say, 127 rows, counting the 0. And then let's hop over and look at how many rows are in this top table. And we have 62 rows. So clearly we're picking up this bottom table as well, which we don't want. So there's a number of ways that we can choose to handle that. One thing that we can do, I see that, well, let's look at how the data frame looks in that middle area. So, of course, with the data frame display, the middle gets cut out, so we can use iloc to look at some range of rows. So we know that was 63 rows, so let's just look at rows 60 to 70. So now we can clearly see here the table ending, and then we can see a number of blank rows, and then we have the next table starting. So there's a number of ways we can deal with this to be able to say, let's cut off everything after the table, the first table. So ultimately, it's really easy to drop rows which have all missing values. So I'm not too worried about these ones. Once I drop the missing values, these will be gone. It's once we're getting to here. And we want to try and pick something that's going to be consistent as we load in data for different companies or different time periods. So, this is the first kind of distinctive marker that we see for the second table, but we can see this is very specific to the date. So perhaps not a good choice to try and target. Now we do have this description here in the next row, signifying that we're starting the next table. So that seems like an appropriate thing to target because we can assume that that is going to be the same for other time periods and other companies as well. So we can try to target that row. So that row is going to be where the description is equal to description, right? So by that, we're now able to target this second header row, and that way we know we've gotten into the next table. But we don't want to cut off just that. We want to start cutting off from the row before. So if we take the index from that, we get row 67. We pull the first value out of that, we get actually the number 67. And then if we subtract 1, now we get row 66, which is the first row that we don't want to keep. So there, then we can say that that's our fiscal year row index, because now we're talking about row 66 here. And now we can get all of the data frame up until that fiscal year row index. So now we'll have those blanks on the end, but we do not have that fiscal year row, and we do not have the second table at all. So that's a good step. We've removed that second table, but now we also want to remove these blank rows. Thankfully, Pandas has a convenient method for this, drop NA. But we want to make sure that we're still keeping these, even if there's no floating rate, it can still be a valid row. So we only want to drop when all are missing. So we put how equals all. And now we can see that those other rows get dropped as well, and yet we are keeping the rows which just have some missing values. So we can do df equals that in order to save it back into the result. And that way we've got now just the first table. So just kind of looking through, one other issue that we see in here is we have these dashes. In Pandas, this NaN represents a missing value. A dash represents that's actually the string dash. And so if we try and do any math with these columns which have the dash in them, it is not going to work. For example, so this is the principal due USD column. So if we try to sum that, we're going to get an error. And it's actually going to say you can't add a float in a string, and that string that it's talking about is that dash which is in there. So in order to fix that, we can use replace on the data frame. So with the same look at the data, if we do a replace of dash with, we do have to go import numpy as MP and have to run that. Then the missing value that Pandas uses is numpy.nan. So we're replacing the dash, which we're seeing here in row 16, with a nan. Let's see how that looks. Now row 16, we have a nan in each of those spots, which previously had dashes. So let's save that back into the data frame. So df equals df.replace. And let me just load it and then clean it again. So now that looks good. We have the right number of rows. And now let's try to do this sum again. Now the sum actually works because we replaced the dash with the missing. So I think this represents a nice concrete step in the process. So let's go ahead and wrap that up into a function. So load details. We can give that a file path. And it's going to use Regexpal and do all these other things which we just did, and ultimately return the data frame. And instead of that specific file, we're going to use the file path. So now we can do df equals load details on that file path, and we should have the same thing, which we do. Great. So now we have to start tackling some of those other cleanup pieces that I mentioned. So let's next tackle the coupons. So for the coupons, we have a couple things to deal with. Let's look back at the sheet over here. So we had the fact that we have this % sign on everything, and then we also have these ranges to deal with. So there's a lot of different ways to tackle this problem. You know, you could just use like string methods, like we can, we have a string 4.0%, we can do a strip and strip off the percent sign, and then you're left without it. And then you can take float of all that, and we get back to the number, and then divide by 100, and we get that actual percentage. So we can use this kind of approach, but this is not going to work for the range, where we have the range like 4.5% to 5.5%. So we could use similar approaches along with split. Split will let us take this string and split it into a list on a delimiter. So here we're putting the space dash space as a delimiter, and now we have these two coupon rates, which we can do that kind of approach with, and then take the midpoint of the range. So that works perfectly fine, but then you have to come up with a way to detect which of these two styles of strings you got. You could do a split and then check the length, because if you just split that, you're going to get a list of length 1. If you split that, you have a list of length 2, so you could compare off that to make the distinction. So that's one possible approach. The approach that I'm going to look at in this video is actually using regular expressions. So regular expressions are kind of a mini language within Python, and they also exist in many other programming languages and actually have nearly the same syntax across different programming languages. And they're a way of parsing strings. So they let you match any kind of pattern in strings and extract any parts out of them that you want. The downside being that they do tend to be a little bit complicated to write and read, because they're their own little mini language, but they're extremely powerful, so I do recommend taking some time to try and learn them. And I think I will be releasing at some point in the future a video dedicated to regular expressions, so I'm not going to spend a whole lot of time on them here. But we want to write a regular expression to be able to match this pattern of a percent and a dash and another percent, and then extract the two numbers out of that. So in order to write regular expressions, I like to use a little tool to help me in that tool. So regex is the abbreviation for regular expressions, and Regexpal is the tool that I like to use to help out. So this tool is nice because you put your whatever string you're trying to match down here, and then you start typing your regular expression up here, and it will show what you're matching. So again, this is not a video to teach you regular expressions, so the syntax is not going to make any sense to you, but you'll see kind of how this works. So \d will match numbers, and so now you can see it's highlighting the numbers here, and if I put a dot, then you can see it's matching the dots as well, number and then dot. Actually, dot means any single character. If I escape it with a \, then it means the literal dot. And when you highlight over this in Regexpal, it also explains to you what you have here. And so we then can make a character group out of this, and then say that it repeats one or more times. And now we're matching, any number here, regardless of how many decimal places are there on it. And then we're going to have a percent sign, and then space dash space, and then basically the same thing over here. Yeah, entire same thing over here. So what am I missing here? There we go. And then percent. And now it's matching completely. So this is our regular expression. And then one more thing that we want to do is put groups in here, and groups are going to allow us to extract certain parts of that string. So ultimately you want to extract this here and this here. So let's put those into groups with parentheses. So that whole thing is grouped, not the percent sign. And over here, same thing, not the percent sign. So now we have our regular expression, and we can bring that back over into Python. So this would be the range pattern. And I'm going to import RE for regular expressions. And it's going to be re.compile is what we're going to do here. Again, I'm really glossing over the regular expression stuff. I plan to do a whole video on that later. But you're just seeing quickly how it can be used here. So then we have our string. So let's just define that as A. And then, or let's say that's coupon string, give it a better name. So then we can do range pattern dot match on the coupon string. And when we get a match, we're going to see something like that. When we don't, then you're going to get none as your result. So what you can do is then say that's the match. And then if there's a match, then we can extract the result from it. So then the bottom percent is going to be match.group 1. Group 0 is the entire thing. Group 1 is the first spot you put parentheses. And then the top percent is going to be match.group 2. And let's just make sure that we have those correct. Yep, we got those. And we can then take the float of each. Yep, so now we have the numbers. And then the midpoint is going to be equal to the top percent plus the bottom percent divided by 2. So the midpoint, we should get 5 for that, which we do. So now we can make this into a function. So we can call this standardize fixed coupons, fix the coupon string as an argument. Okay. And so we're going to return the midpoint in that case. But what about in the case where we don't have a match? So we basically have two alternatives here, and the other alternative is this, where we already looked at. For that, we just do this kind of approach. So if it's not a match, then we're going to return this on the coupon string. Let's just save the divided by 100 for later. So now we have a function where we can give it, say, 2.5%. It gets the 2.5 out of that, or we can give it a range, and it's going to get the midpoint of that range. So now we can apply this to the correct column. So that's the coupon base rate column. So we're going to apply standardizing the fixed coupons. And we get an error. Expected string or bytes-like object. So I'm just going to quickly look at what that error was using the built-in debugger. And we can see it's because we're getting a nan here. There is a missing value. So we do have to handle that in here as well. if pd.isNull coupon string, then we want to return the coupon string. Okay, now this is working appropriately. Okay, so we can then have this as part of our cleanup. The coupon base rate, we're going to apply this. Okay, so now what do we want to handle next? Let's look at the floating rate coupons next. So for the floating rate, we have a similar thing here, where for the floating rate, most of the time here, we just have this NA, and that has been converted to NaN over here, so it already has missing values appropriately. But what we're going to need to handle is these LIBOR plus. So we can use a similar regular expression approach. So I'll bring that over to Regexpal. Let's now put that as our test string. And so what we're looking for is the string LIBOR plus, but plus is a special character in regex, so you got to put a backslash. And then we're going to have numbers as well as decimals, and one or more of those, and then a %. So that's our regular expression for that. So that's going to be the LIBOR pattern. Okay, and I'll move this up here as well since it's also done. And now we can use a similar approach. So LIBOR, let's give that example coupon string LIBOR plus, and try a similar approach. So we have the LIBOR pattern that match the coupon string. We can see that's a match. So that's the match. And then if match, oh, we got to add our group in here. So here the group is going to be around the number again. So if match, then the percentage is going to be the float of match.group1. And then let's just say that LIBOR was 1%. Then we're going to return the LIBOR rate times 100, because this is in whole percentage points, plus the percentage. And not quite returning yet, we're not writing a function. So this would be the the overall rate, and then we can look at that rate. LIBOR, just LIBOR, and we get 1.75. So that appears to be working correctly. So let's wrap that into a function. So standardize loading coupons takes the coupon string as well as LIBOR, and it does this. And just in case there are just normal rates in there, we can throw this in there. And we'll also throw our catch for missing values as well. Okay, so now we should be able to take our floating rate column and apply standardized floating coupons, and pass it the LIBOR rate. And it seems it did not work appropriately. For some reason, our string was getting through without a match. Oh, because we never returned. Okay, so then we want to return the rate. And now it seems to be working. Let's just drop an A in there so we can see the two. Yeah, they were both LIBOR plus 0.75, and so that's correct. If we put a 2% rate, now we're getting 2.75%, so everything looks correct. So we can now add this into our cleaning approach. So yeah, floating rate equals that. So now this is starting to get fairly cleaned up. We have the coupon and the floating rates both handled well. So now we want to combine the two. So we can create a coupon column. So that's going to be equal to the coupon base rate column. And then we can say, well, wherever that's missing, we can fill it in with the floating rate column. So now we have the coupon rate here, and it should be taking the values yeah, so I got the rows where floating rate's not missing, and we can see it is indeed getting filled in for the coupon. So everything is working appropriately. And then in order to do calculations with it, we want to get it to decimal. So df coupon equals df coupon divided by 100. And now that looks good. So now the coupons are cleaned up, and we just have the maturities to deal with now. Let me just get all this group together and bring this up with my other functions that are now working well. Okay. So now we got to deal with the maturities. And so with the maturities, we talked about how, well, one, we got to get it to date time instead of just a string. Is that how it is now? Let me look at the data types. Maturities object, so yes, it's coming as a string and not a date time. And then we've got to deal with this year issue as well. So let's see. What is the column name? So maturity. So trying to look for where, okay, one of these years. So let's grab 20. That's where we have a year. So what is the type of that? That's actually coming as an integer. And then one that's a date is actually coming as a date time, not as a string. So we want to let these basically pass through as they are. They're already in date formats. That's what we want. But if we're getting an integer, that means we have just the year, and then we've got to convert it. So we can use Pandas' toDateTime to do the conversion for us. So if we just say, December 31st of 2020, it will be able to take that and turn it into a timestamp, which will work for the datetime purposes. And so if we, just have our year, then we can just format the string to drop in the year, and it will do that conversion for us. So we can do that along with some type checking in order to standardize the maturities. So, if is instance, that's a way we can check the type of, and here let's make this the more general maturity because we're not going to know coming in whether it's a year or a date time. So if it's an integer, then that's going to be our result. And otherwise, basically, it's passing through. So let's just go ahead and make the function for that. Standardize maturity dates. So if it's an integer, then return the date time of the end of the year. It needs to be maturity there. If it's not, I guess it could conceivably get loaded in as a string. So if it's not a string or an integer, then we're just going to return the maturity. So if it's a date time or if it's missing, then just return it. And then basically we get here if it's just a regular string, and then we can just return it. So now we give it a year, that will give us the end of that year. If we give it a date time, then, well, let's just throw it at the data frame and see. So df maturity dot apply standardized maturity dates, and we can see this indeed has worked for us. So we didn't get any errors. We remember row 20 had that year. We can see now we're getting the end of the year for that. And the missing values are passing through just fine. So that becomes the next step here in our cleanup process. We're going to overwrite the maturity column with that. And that has allowed it to become a datetime type as well, now that everything is date. So then we just have to convert that. I'll just put this over here because we're done with it. Then we have to convert the year or the maturity date into a number of years from today. So I'm going to import datetime, and I already covered this in a prior video on handling the market value of debt in Python. So I'm just going to copy the function that we had from that, this year until from date. So it gets today's date and then looks the difference between the date we're passing to it and today, and ultimately gives you a number of years. So then we can just apply that. So we take maturity, now that it's been all cleaned up, and we apply the year until from date, then we get the number of years. So we can add that in here as df maturity years equals that. And now we should have that coming into the data frame as well. So one last step is to determine whether we have enough information to be able to value the bond. So there's a few things that will make it invalid. if if the coupon is missing, which here we can see the rows that have a missing coupon, then we're not able to do anything. If the maturity years is missing, that also is invalid. We have no way to know the value if we don't know how long it's outstanding. And then if the maturity years is less than 0, that means the bond is already expired. And so those are going to be invalid as well. So we can use loc in order to catch all these three things at once. So if we just wrap this in parentheses and then put this pipe operator for or, and then we can put these other conditions in there as well. Wrap in parentheses, pipe, and then if the coupon is null, so now that should catch all three of those cases. So then we can use that to create a column which represents whether the row is valid. So yeah, we can see we've got the negative maturities, we can see we've got the missing coupons, and we can see we've got the missing maturities all caught here in one filter. So what we can do is we can say create a validity column and just set it to true. But wherever any of those things, conditions are met for it to be invalid, then we set it to false. So then we have this validity column, and you can, oh, I accidentally had it set the entire row to false. We want to then put a comma, and then have just set only the valid column. Let me get a new data frame and then do this again. And yes, now it goes false. The rest of the row still stays there, so we can do other things with it, like just take it at its principal instead of doing an evaluation. But now we can differentiate between the two. So let's just create a function out of this. So we can call this assign validity of bonds. And this is going to just work in place, so we don't even have to return anything. I'm going to put this up there. And now we can just call this on the data frame at the end. And now we have that in there as well. So this is all working. Everything is all cleaned up now. It's ready for you to go do evaluation from here. But let's just wrap all these steps into one further function. So we can call this load and clean statement or that details. And that's going to take the file path. It's also going to take the LIBOR rate. And it's going to do all these things. And this is going to be the file path. And it's already using the LIBOR in there. And then we're going to return the data frame at the end. So now we can just do load and clean details on the file path and give it a LIBOR rate. And we'll have the data frame all cleaned up and ready to go. So now we have our code working to be able to do all this cleanup, but it's kind of, a decent number of lines of code here. It's definitely not ideal to copy paste this into every project, and if you did and you needed to make some updates to it, that could cause some issues because then you've got to go back and update it in every place that you've copy pasted it. So really you just want to have it once and be able to use it everywhere. So that's the perfect application of a Python module. Um, so we can create a module in order to uh, use this very easily in any of our models. But real quick, before we do that, I do want to try just loading in different debt details to make sure it works with Pfizer's debt details as well, to see if anything is different there. So let's give that a try. And there it did not work. So what is going on here? You can see you got a key error for the floating rate. So that suggests maybe that the floating rate column is not there. But let's see, let me open these up so we can take a look. And we can see in the Pfizer data that the floating rate column is there. So why are we getting an error? So let's go back over to Python, and we can use the built-in debugger in order to check this out. So let's get back up to our code. So let's look at the columns of the data frame. Floating rate is right there. Isn't that weird? So this is definitely a gotcha that you may face in loading in data from different sources. Now let me look at that directly. Oh, it looks a little bit different now that I pull it out. It's floating \XA0 rate. What does that mean? So it's you know, a little outside of the scope of the course to talk in detail about what's going on here, but basically this is another way that white space can be represented in a file. And so what looks to us like a space is being represented by this \XA0. So what we can do here while we're loading in the columns is just replace any of these XA0s with a space, and then we shouldn't have to worry about it. So I'm just going to try adding that in here. df.columns equals column.replace this \XA0 with a space or call in df.columns. And hopefully that will allow it to work. Awesome. This time it loaded it, and now everything seems to be working properly here as well. And then let's just check. We can go back to Walmart, and everything is still working there as well. Awesome. So this is ready to go. So now let's take this over and put it into a Python module so that we can reuse this in multiple different models. So we can go and create a text file, and then I'm going to rename this file. You want to pick a name without spaces, so I'm going to call this capiq det, and you want the file extension to be .py. That's what makes it a Python module. And then we can just take all of this. That's why it was good to gather it all in one cell, and put it over here. And now save this. And so now this is just a text file with a .py extension, which is in the same folder. And now let me just totally start a new Jupyter Notebook. So over here, we've never defined anything. And so we don't have any of those det loading functions ready. But let's try import capiq det. So we do that, and we can see it was successful. And now when we do capiq det dot, we can see that we have all these functions that we defined in what was previously the Jupyter cell, and we brought over to the Python module. So now we can do load and clean det details. So df equals, and we're going to do that on the Pfizer det details, and say our LIBOR rate. Let's just say it's 2% now. That's the libellum. And there we go. Now we have our data frame cleaned up, ready to go. And we don't have all that code in this Jupyter notebook. So now we're able to take all this detail of all of this loading, cleaning process for the data pipeline and just offload that so that the reader of our model does not have to care about how all this works. It happens in the background through this CapIQ det module. And now this module can be reused in as many different notebooks as you want. And if you go and make some changes, like we had to do to be able to handle the Pfizer details, then that's going to go and apply for all your different models. So maybe you decide, okay, well, I'm going to add some functionality which prints out some summary statistics and totals up the principal to make sure that you have the right amount of principal. Well, you just go and change it in this module, and then all your different models which use this module are going to get that functionality. So there's a lot of power in restructuring your code to use modules. So that's an overview of how we can clean up capital IQ det details. 100% automated in Python. So now it's ready to use to value all of the bonds and calculate the total market value of debt. And we also covered how to take that code and offload it into a module such that it can be easily reused in multiple different projects. So thanks for listening and see you next time.